All right, peoples, we are now going to go over what we do for differences in two sample proportions. And we're going to look first at the confidence interval. You excited, baby? Yeah. All right, so let me tell you about, a real life application I had using this. It was actually, a couple of years ago. I met this lady at the park. By meet, I mean she approached me like, "What are you doing?" I'm like, "I'm walking my duck." She's like, "Why aren't you on your cell phone?" I'm like, "I'm not on my cell phone." "Yeah, you're not on your cell phone because I'm here." I'm like, what are you talking about? Like, you young people always use social media so much. You guys need to get out and live. I'm like, "What?" "Yeah, you guys use Twitter, Snapchat, InstaFace, blah blah blah." She was going off on like all this, and I'm like, "What, you think old people don't use that stuff?" She's like, "Yeah, but not as much." "Probably more." "No, I can prove it." I'm like, "You can prove it?" I kind of became interested. How? Actually, I've actually been collecting data for centuries. Like, what? "Yeah, in the last 2 weeks, I collected data on some samples proving this." I'm like, "Well, let me hear it." So what she did is she collected a sample of young people. It was 312, I believe. Let me see, 316 actually. And from these young people, she surveyed them, and 26% of them, or 0.26 of them, had a Twitter account. She also took data on old people, and she had 532 old people because they have nothing else to do, so she got everyone in the group home, and they had a proportion of 0.14. So 14% of them had a Twitter account. There should be two. So we got the youngs, we got the olds. And so she's like, "See, when you compare the proportions, 0.26 and 0.14, you get 0.26 minus 0.14 gives you 0.12. So there's a difference of 12% that young people use Twitter more." I'm like, "All right, well, that's interesting because, first, did you take a random sample?" I asked her. She's like, "Of course I took a random sample. I'm a professional." I'm like, all right. So then I just, sit there for a little bit, and she starts rolling away all happy in her, 5 story wheelchair thing. And I'm like, "Hold on. Actually, you can't say that this is true." And she wasn't that far, she's old. And she turned around like, "What do you mean? Like, you only took samples. These samples don't mean that they're accurate and that they actually are equal to the true population parameters." And she's like, "Parameters? Wow, you're really smart, aren't you?" I'm like, "Yeah, I'm really very intelligent." She's like, "Okay, well, so then what should we do?" Like, "We can do a couple things. Let's look at some statistical significance and let's run and calculate a confidence interval. Let's start with the confidence interval because I like confidence." They're like, "Okay." And we agreed on doing a 90% confidence interval for estimating the true difference, because this is P1 hat minus P2 hat. But we're trying to estimate the true population proportion of differences. This is basically what we're trying to estimate. This represents the true proportion of young people that have Twitter and the true proportion of old people that have Twitter in their entire populations. What we took were samples. Now, what we're going to do to make a confidence interval is basically the same principles that we did for a confidence interval for just one proportion. So let's go back and review this. Where let me go down here. Remember, we started with a point estimate. Let me use like a different color. This red's kind of in. Be back. Point. That. Oh man, it's blurry. Red it is. Point estimate. Started with just our sample proportion, p hat. And then from there, we had to, create an interval. So we added it and subtracted a margin of error. margin. Don't mind the handwriting. The plus minus, and this margin of error was made up of our critical value, z star, times our standard deviation of the statistic, or standard error, we say. Estimate of the true population standard deviation. So we have our critical values. Well, let me just write it over here. Critical values. And standard error. Now, since it's just a review, don't mind that it's messy. But now we're trying to estimate the true difference in population proportions. So this is our point estimate. So what happens is now that this, instead of it just being p hat, it's going to be p1 hat minus p2 hat. Because when you take this, it's just going to give you another number. It's not like going to give you some like crazy equation. In our case, it was 0.12. And we did the same principle, plus or minus our margin of error, which is made up of our critical value, because these are samples or proportions. And we're going to have a different equation for the standard error. So let me write this all out over here. We have P1 minus P2 hat plus minus Z star times, and it's going to be cool looking, P1 hat times 1 minus P1 hat over N1 plus P2 hat times 1 minus P2 hat over the second sample size, N2. I know what you're thinking. You're like, man, I'm really excited to have to memorize that. But the thing is, you don't have to memorize it because you know, form this sheet. So yeah, it's going to be just exactly right on the back. The P1 hat times 1 minus P1 hat. So it's all good. So now it's just going to be a tedious calculation. So make sure you plug in the right values. So let's see what we get. So we're going to have, again, 0.26 minus 0.14 plus minus. Oh yeah, critical value. Remember that? Where's our markers? No purples? Oh, perfect. Here we go. So let's quickly review what this means. We're trying to find the 90% confidence interval. So for that, we're looking at a normal curve where there's 90% area in the middle. So we're looking at the left endpoint as a negative z star and the right endpoint as a positive z star. Because this means then there's 5% to the left, or an area of 0.05, and 0.05 over here. Why do I say that? Because in your calculator, you have this inverse norm function, which I've been using for like the last 9 chapters. And that'll allow you to just find the z star quickly by going to distribution, inverse norm, 0.05. So inverse norm is going to look like this. And you just type the left area. If you have a more advanced calculator, it's really easy because it'll just say what you're plugging in. Now this gives a critical value of 1.6448, or let's just round to 1.645. All right, now here's the fun calculation. Let's make sure we do this correctly. I'm not going to do every single step on the board, but just make sure we plug in 0.26, 1 minus 0.26 of 0.74 over 316 plus 0.14 times 0.86. Whoa. Hey guys. Over 532. calculating this, you will get 0.12 plus minus 1.645 times the square root of 0.0008. Let me see. 35176. So something like this. Oh. Man, it looks intense. Yeah, and it's really cool. Yeah. Finishing it off. So 1.645 times the square root of that. 83517. 0.00. We get about 4.7%, so 0.047. Where should I write this? I gotta erase something. No, I can fit it in here, can I? Sorry, baby, gotta move you a little bit. No, not that. Let's go over here. So 0.12 plus minus 0.0047.5-ish. And since remember it's confidence intervals, you're going to add and subtract this to that. So the upper bound will be 0.1675. Hey guys. And the lower bound will be about 0.0725. Right, so here's our confidence interval. So this tells us that we're 90% confident that the true difference in population proportions lies somewhere in the interval 7.25% to 16.75%. Yeah, so then I tell the lady, hey, what do you think now? So what do you have to say? I'm, very serious when I say this, and she's like, what do you mean? I'm like, what do you mean? We give each other like these, weird stares, and she's like, nice try. You're trying to confuse me. And I'm like, no, I'm not. You are wrong. I'm not wrong. Young people use Twitter more, right? Yeah. Okay. I'm like, fine. All right, fine. I guess you're right, sort of, because it's only 90% confident. He's like, oh. I'm like, yeah, yeah, so what? Maybe it is true that young people use Twitter more. But what about a significance test? What about using that? And she's like, I never done that before. I'm like, are you ready for this? And she's like, I have to go to the bathroom. And then she left. So we're going to do this in the next video because she went to the bathroom. So stay tuned. Make sure you subscribe and tell your friends and tell your parents. And I hope this helps. If it doesn't help, then probably shouldn't subscribe or give me feedback. And I'll see you guys later. Bye. Bye, guys. Thanks for watching. Mm-hmm.